All right, so today we're checking out a Defrost time clock. This is a 8145-20, 208 volt time clock with time or temperature termination. What that means is that the center dial is set to a duration, and this little terminal X right here is set to temperature. On the evaporator, there's a defrost termination control that when it hits 45 or 55 degrees, sends voltage back. And between this neutral and X, we can flip it over and take a look, you have this little solenoid that runs up here. This is a defrost termination solenoid. When it's provided voltage, it pulls up, which kicks the unit out of a defrost. The only other way that it can come out of a defrost is time duration. And that's actually on the pin setting on the back side. When the pin rolls past, the 45-minute mark begins, and then the time durates out. That center knob that's right in the very bottom can punch it out. Now, one of the problems that happens with these time clocks is because they run 24/7, they can actually wear themselves out. The gearing to the motor, the reduction becomes too strong. And this one I actually found couldn't start a defrost time clock on its own because, as you can see, the drive motor's actually become too weak to drive the whole system. So the two parts of the system that this operates are the refrigeration components. When it's in a cooling mode, you'll have power fed out on one set of points. When it's in a defrost mode, you'll have it set out on the other set of points. What can happen with these units after old age is those points actually become burnt on the back from arcing damage. When the unit kicks on, I think you can see right in there that there's some arcing damage. If that arcing damage becomes too bad, these brass risers that actually make the connection point can heat up and become distorted, and they don't actually make when they're supposed to. So customers will experience no defrost occurring during a defrost time. Refrigeration sets down. The customer will start seeing temperature rise due to ice buildup over the evaporator. If you don't have airflow through an evaporator, you can't pull the BTUs out of the air traveling through the evaporator. You can't drop the temperature of the box.